I got a text message from Duke Power saying they were cutting my power off for repairs at 10 today. And I said, who works on Duke Power on Saturday? You know?
You would have been out of luck.
I panicked and I didn't read further until I came back to it and saw that it was 10 p.m. So they're going to be working 10 p.m. Saturday night just to mess up my CPAP.
Oh, yeah, right. You got one of those?
Oh, yeah.
My brother has one of those. Fortunately, I don't have to worry about that. You got the mask. It looks like a jet pilot.
No. It's I've got this stripped down, kind of just a little strap that comes here under my nose and then runs back around the back of my head. So,
how do you keep that from falling out while you're sleeping?
I'm just that good.
Well, my wife has one, and the machine itself is because she also has an oxygen machine. It's in a closet, so we both can sleep. But yeah.
Well, the company that made mine, I thought this was pretty interesting. I had an older one I had two actually. I bought one on Craigslist, and then the other one I got through the regular channel. But it was an older machine. It was like 2003 or 6 or something like that. But this company said there have been claims that some of these, the foam in these machines breaks down. So we will offer you a $50 toward a new machine, or we'll replace the old one. I said, after 10, 15 years, they're going to replace it. I didn't believe it, so I took the $50 on one of them and then went through the process on the other, and I got a new machine. And it's so quiet, Pat, you wouldn't believe it.
Well, that's great. Yeah.
But I think those oxygen concentrators make some noise too, don't they?
Yeah. The oxygen is the real big one. The CPAP turned out, she was having noise for a while, just turned out to be she needed to replace the hose.
Yeah.
And then once that happened, it got quiet.
Well, if they do come loose, they make noise too. So,
Yeah. Oh, yeah.
Gene's like, I couldn't believe it when the VA gave me hearing aids, these Bluetooth hearing aids, and told me that they were good for life. They died on me 2 or 5 years from now. I can just come back and get the latest upgrade.
Wow.
As long as I live. Like, wow. Hey, Pete.
Hi, guys. How are you?
Good.
Somebody's got a noisy.
I think that's Larry B. He's probably in English. What it sounds like. There you go.
We scared him.
Thanks, Larry.
Brent muted him.
No, actually, he probably muted himself.
He probably heard me.
I was getting close to, but I was hovering over the button.
Well, when Pat starts his presentation, I'll turn my video off and my microphone so it's serve.
What I'll generally do when someone starts talking, presenting, you can, and anyone can do this. Like, I have no special power here. You hover over their Windows details and you say mute everyone else,
Right.
and that handles that.
Yep.
Cool.
Hey, Rusty. Rusty is silent.
He's sleeping.
Playing it safe today.
You guys notice my different background today?
Yeah.
That's because I'm down in Florida.
You hightailed it to the warm climate, huh?
I sure did. I drove down Wednesday. Wednesday morning when I got up, it was 18 degrees up there, and the wind was blowing about 15 miles an hour, and I had to load the car in the freezing cold. And they said, it's time.
I just spent some time down in Florida. So in the space of the same week, I was at the beach and, enjoying the fall colors here. So it was very confusing to me to be, out in the sun and on the beach and in the water and so forth. But another cool thing is I saw 2 bald eagles in the space of a handful of days in 2 completely different environments in 2 completely different states. One was less than a couple miles from my house down by the river here, the Ivy, and the other was along the beach near Fort Pickens in Northwest Florida.
Wow.
Yes. They seem to have a lot of eagles down here for some reason. I don't know why.
Where I was north of Tampa, we had some albatrosses, but no. They
Those
were
are big.
in the big cell towers.
Yeah, those are great big birds, aren't they?
Yeah,
Mm.
and there was one that had a nest in the outfield of the Blue Jays spring training camp in Dunedin. And I don't know, I think they might have relocated it because they do generate some mess.
Our cell tower in our neighborhood in Cape Coral, Florida, had a osprey, and they were pretty noisy, especially when they had babies.
Are they the little white birds or?
Osprey are
They're like
are-
an eagle.
yeah, they're like eagles, a little smaller.
Mhm.
They don't have, I think they kind of have a little bit of light head, so they can be mistaken for eagles at times. But it's kind of hard to tell the difference between an immature eagle and an osprey because they look pretty much the same. They're because they haven't got the white head yet.
Interesting. When I lived in Pensacola for the first time in my life, it was a long time ago, I saw armadillo. Not something you see every day.
You can see them every day down there.
Oh yeah.
They're considered a pest down here. They dig up your garden and the grass and.
They are not a
Walk right up
rarity.
on them.
Yeah. It
You're
was
not
weird to
afraid
not
of
have them up here. Basically you trade the armadillo for the groundhogs, although the groundhogs seem to be really good about not getting in the road, even though they're always by the road.
them. Right.
Can anybody remember when the last face-to-face meeting was and where it was?
I certainly remember where.
Yeah.
Earth Fair.
Where?
Earth Fair.
No, the South
library.
Library.
Oh, yeah.
Oh, South Library.
Oh, yeah.
Yeah.
Okay.
And when I'd have to look at some notes, but I would guess what was that? March, April? I don't
March,
know.
April of 20.
20.
Wow.
Yeah, sounds like.
Yeah, they apparently, I can't remember whether we were masking for that meeting but yeah, I can't remember why we were at the library instead of at Earth Fair.
Well, that Earth Fair had,
Earth Fair went belly up.
yeah, Earth Fair had hit
Oh,
Fun
that's
Way
what
at
it
that
was.
point
That's
and had
right.
not returned in its Whole Foods incarnation.
Yeah.
And so we needed a new place to live, and the idea is we were going to try places out. And that one looked pretty promising. We didn't like that it didn't allow food. Parking was good. I mean, it was probably going to be the place, barring, other, like it sounded like Steve had figured out an option for UNCA, but it was seasonal, so we wouldn't have been able to do that year round.
And we looked at Panera Bread too, and they would have hosted.
Yeah, that would have been okay, but less private, obviously. No way to project to a screen or anything. And no, we weren't masking because that wasn't really a thing yet. But we were trying to social distance, as I recall. So we spread the chairs out and
That's right.
so forth.
Mhm.
Yeah, social distancing and washing your hands.
Still good
Yeah,
ideas.
Back then, washing hands seemed to be included in it was considered to be more of a vector or pathway than it is now. I mean, I think it's pretty well accepted that things are airborne mostly.
Yeah. Oh yeah. No. Yeah. No. That was and that was when CDC was afraid that there would be not enough masks for the professionals.
Yeah.
So they were not recommending masks because of that.
Well, I think they also shot themselves in the foot by suggesting that, like, by being perfectionist about the mask, like, well, if you're not using N95, you may as well not use a mask. But clearly, based upon the flu numbers that happened when everyone was masking, they do work.
Yeah.
Mm-hmm.
Yep.
Well, now the question is, how many will continue to do boosters, because so many people, even people that have had an official booster, still end up getting COVID at one time or another, and then that counts as some form of ad hoc booster. And we don't really know. I'm not seeing good articles that discuss the recurrence after a definitive COVID episode. What is the rate for second COVID events among those that continue to boost, and those that just decide, well, I'll run with what immunity I have. I'm just not seeing any articles out there on that question. It's almost like it's just not, you would think it would.
Well, they for a while there, they gave you cards with the shots that you had, so they were recorded somewhere. But the one I just had, they didn't ask me for one. They
don't care.
Record it. I think I'm on like number 6 or 7 shot.
Yeah.
Yeah.
And the thing that's already clear is that the booster certainly does both things. It reduces your chance of having any COVID, and then reduces your chance of having severe COVID. And that's the key thing that would be important in a study of outcomes for second event COVID. Our second event COVID symptoms less, because I think most people, even if you get boosted, the prevailing view is, well, I'm going to get COVID again. You're waiting for your second COVID event, and just hoping that it will be a mild one, and then hoping also that it won't be so silent or stealthy that you end up becoming a vector to somebody else. And that's the most problematic thing.
I guess, they started calling it an epidemic, but now it's a pandemic, and that pretty much means it's like the regular old flu. Everybody's going to get it, so
Yeah,
I've had it at least once, and I got a luckily fairly mild dose, I think.
Well, there's definitely other benefit to the booster. I've known several people now who've gotten the second one recently before they got the second shot, and that's that the claim is that it's only good for about 6 months anyway. And then the newer strains, because the thing is like the flu, you get a flu shot every year because it's not the same flu. Well, this is what's happening with COVID. And so people who are not getting the shots are much more likely to get the newer strain, whatever's running around.
Mm-hmm.
I do think it's.
Go ahead. Sorry.
Yeah, I do think it's going to be like the flu shot, at least unless it just kind of disappears on its own or becomes so because it's obviously not the disease it once was. And if it just continues to weaken and be less of a deadly thing, maybe it won't be as a concern. I got mine because I had to get flu anyway. So it's like, if I'm going to get flu, just jab me twice. But it just feels like it's still worth doing in the cold and flu season. Get it while you get the flu shot, and you're covered during that season when you're meeting with family. And my son has a great habit of coming home from the Army base and giving me whatever's going around there. So, and COVID is one of those times it was COVID. So yeah,
It's
I
sort of like having a 6-year-old kid again.
yeah, very much so. The
Hey,
6-year-olds are
Alex.
probably better about washing their hands and so forth.
Hey, Alex.
All right. It is 10 after. So those who will join probably have joined. So we welcome back Pat after a significant lapse. Pat just doesn't want to be with us unless he can shake hands and
Cool.
see our faces. So
Yeah,
direct
and
in
cool.
person. He wants to be a disease vector, or
That's true.
or not at all.
Golden
So
aspiration.
I am kind of itching for some sort of in-person thing. If anyone has any specific ideas of what we be the most interesting sort of thing, coffee bar, restaurant, whatever the folks would want to do, just say what you'd like to do. Maybe do that in the chat, since we do want to get Pat going today. But yeah, it'd be cool to see you in person again. It's been a minute. So without further ado, have we started the live stream?
Yeah.
Okay, cool.
When I checked in, it said it was running.
Yes, we have.
Okay.
Well, then I never said it, but welcome to the November meeting of the Linux Users Group. And today we have Pat presenting on Linux from scratch. So Pat, take it away.
Okay. Let me see if I know how to do this after my first run. The screen sharing down here. There it is. Oh, somebody needs to authorize me, it looks like. Here we go. Oh, select Windows screen. There it is. Yeah, there it goes. Okay. Forgot, I have 2 screens, so I had to remember how to do this. I am sharing, is that correct? Okay, well, let me know if for some reason you're not seeing what's on my screen, which is which I'm about to bring up.
You're good, Pat. You're good.
Okay, good. So, in the spirit of the fact that I haven't done a presentation with any kind of tools in about 10 years, I decided not to attempt anything with slides. But this is actually a LibreOffice document that I think works just as well. The other thing is I've got running a virtual machine, and I have some tabs up on my browser that I'll use for various and odd things. I don't care if if anything is not clear and you want to interrupt me, ask a question, feel free. I don't need to run all the way through. I put it together this week, and so bear with me if I get a little strange. We'll start with the basic stuff, which is what is Linux from scratch, and quite simply, it's building a Linux operating system completely from source. And a lot of times people tend to think of Linux as being the kernel, but when you go through Linux from scratch, you discover that there's somewhere to get up what is an extremely minimal system, about 100 different packages needed, and only one of which is the kernel. and all the other things that go into making this thing usable and are there. And then to get to the next level, to either have a desktop or a web server or a file server, you need to add even more. And that's the project called Beyond Linux from Scratch, which is done by the same people. Real quick, if I can bring this up here, go to here. If you go to this particular website, it's linuxfromscratch.org, LFS, or type in your browser search Linux and then LFS, you can come up to here. And if you notice on the screen there's tabs, and we're on the LFS tabs, and there are several other tabs. The BLFS is the Beyond Linux from Scratch, and I'll talk a little bit about that, which is after you've built a basic system, you can go back and purpose it for something else. And even more briefly, is something called Automated Linux from Scratch, which is really around what you do once you've done one or two installations and you want to keep building these things. Okay, wrong one. So why would you want to do this? Well, probably for most people, particularly if you're only going to do it once, it's just to learn how the operating system is put together. In doing so, you're going to learn a little bit more about the internals of the operating system, what goes together to make it. And you'll also get some experience in actually building software packages, even though the scripts have been written for you. As you go through looking at the scripts, and as I demonstrate, doing a lot of copy and paste, you'll find out the basic method that almost all package developers use for building a system. And having done that, if you ever run into a situation where there's an open source project out there that your distribution doesn't support, you can feel comfortable in going out, grabbing the source yourself and building it. I've done this several times. The second thing, or the third thing about it, which is not nearly as important as it used to be, is with LFS, you build an extremely compact system. The amount of memory that you're going to use up, the amount of disk space that you're going to use up is significantly less even than minimal distributions. Once you start taking it to the next level to put your desktop up or your web browser, it's going to get bigger, but once again, it won't be as big. While there is a 32-bit version of LFS out there, it's not well maintained at this point. There is 64-bit is almost what everyone gets, and that's because I think we've been running on 64-bit hardware for many years now. However, if you have an older 64-bit machine, you may find that being able to build a small operating system for that machine will make it run better. Operating systems, software tend to gain. Over time, they build up lots and lots of stuff. And I know there was a discussion, just to sort of mention this, back about how much memory, how much space your applications and so forth were taking up in memory. What you have to recognize is it's not just the applications that take up memory. Your file system, in order to run efficiently, uses a lot of that memory. And if your applications begin to take up more and more of your real memory, there's less and less of that part of the memory for the file system to be able to use. And amazingly enough, the system begins to get slower, even though it's not running out of memory. It's just running out of memory for the file system. The next thing about learning from source is that you do learn to do some basic administration. There's a lot of stuff that gets done for you when you install a distribution. They set up all sorts of default configurations, and most of the time this is going to be okay. However, you may find things that you want to change, and when you do LFS and DLFS, you have to go in, and many times you may be copying initially something from the LFS book you will a lot of times make changes, make it fit what you want to do. So you learn how to do that. And again, this kind of goes along with the next bullet, which is learning to modify various parts of the system. And the last two come more from people like me that still do software development, is that sometimes you can have bugs that occur and you go out, and I'm really good at doing searches for bug problems, but not always does anybody have the same problem you have. And that may have something to do with your unique hardware. You get some flavor of figuring out how to search for these things, how to gather the information to tell you what's really going wrong. You do this because as you make procedural mistakes within building LFS, you learn how to go back and figure out what happened. And one of the, I think, at least to do it once, a fun thing is called configuring your kernel, which is where you will learn how freaking many options there are within the Linux kernel, because it's designed to run on lots of hardware, and it's designed to run with hardware that most of us never deal with. And be able to set up, get your system to boot is, I found it to be anyway, the first couple of times a fun process. This is also where you get into the whole memory footprint thing, and we'll talk about that later, because the difference between building your own kernel and getting one from a distribution has to do with what's in the kernel image itself and what has to be brought in to make it run. And the last thing, which sort of relates to this one, is learning to configure the boot process. If you've never had to deal with having multiple operating systems on the same computer, it can be a little daunting. Going through LFS simplifies it quite a bit. And this is whether you're talking about sharing with Windows or just talking with multiple Linux systems. So, having talked about the advantages, there are obviously disadvantages. The biggest one is there is no maintenance system per se. There is no package update service such as RPM, dpackage, pacman, etc. You have to apply your fixes manually. However, there's a couple of things. First thing down here is the mailing list, and this is a good time to show you that. If you look within the LFS project itself, you'll find a place for mailing lists, and there's a bunch of them. The important ones are the ones with the word support at the back, the LFS support and VLFS support. If you're having problems and you can't figure it out, you can of course become part of these mailing lists and then submit questions. You get very quick answers relatively. You'll find that most of the current developers actually live in Europe, so there can be a time lag because of that. But they're good about answering questions. Plus, there are lots of other users on there that can help you out. Second thing is it, and if you'll notice on that same page, if I go back to it, there's a pointer to archives. And this is all the support messages, questions that other people have asked. Often you can find the same problem you're having that someone else has had and get a solution to it. And finally, each of the releases, and we'll go take a look at that, has a section where the developers are tracking security issues. Security issues come up. So they've built and published the system to be built in September 1st of this year. And in the meantime, here's a bunch of security advisors. These are things that have happened. And they tell you, for instance, the one that we're currently using, 12.0, it says these are the security issues for 12.0. And this is just for LFS. The LFS has its own. And it tells you what the various problems with and how to fix it. This is going back and doing your own maintenance, but they do help you to tell you how to fix it. And finally, I mentioned this ALFS system, which is automated Linux from scratch. And when you go back to the main pages here, we go back to Linux from scratch here. Let me go back to the project page. And you'll notice there's a read online here. And you'll look and you'll see not only is there current stable, but there's current development. And so I'll look at not the system D one, but the other one. And here's the page, and notice up at the top it says R12 mumble mumble. Well, this is what they're doing to go to the next release. So they are tracking and updating various sources. And this ALFS system can be used to pick up the changes. More about that a little later. So the final thing is, in the the what's no fun parts, it's the system, entire system is upgraded every 6 months. It's pretty much on clockwork, March 1st, September 1st. And this is, again, similar to what you would get with the other distributions where they make major updates and you go and rebuild. If you decide to keep building the system, this is a good place to start to learn how to use ALFS. So from there, talk about the actual process that we go through for building the system. First thing that happens is you have to sort of get used to the jargon that I'm going to use here. There's a host system and a target system. And the host system is where you're going to actually do the build, and the target system is what you're going to build. Very often, they're going to be on the same hardware, though it's possible for them to be on different hardware as long as the two machines are sort of code compatible. However, you still must do a large, you can do the initial parts of the build, which includes creating the tools that are going to do the actual build. That can be run on many different machines, but when you want to do the final build on the target. And it looks like something got misspelled up here. So, however, the way that I do it, and I do put the build on multiple machines, the first thing I'm going to do is build it on a virtual machine. And in fact, this is a virtual machine. Notice it's running Debian 12. When I went to do this recently, I decided to check that out. And this is where I'm on this virtual machine is where I'm actually going to build my LFS system. When I first installed the Debian machine, though, it did not have all the tools that I needed. And I need to do a quick thing here. So for those of you who, this is a XFCE desktop, which is my preferred desktop. And if we go to when we go to build, if you go into the go back up here into the LFS system itself, when it talks about preparing for build, they have this list of host requirements, and this is a list of all the tools you need. But you'll also see here, and here we're going to find the joys of copy and paste that goes along with this whole thing. This is an entire script that I'm going to copy. And because I have my virtual machine set up to allow me to do paste from that machine, I can do that here. So I've now copied this whole script over. And what's the name of it? Oh, there it is, bash. So I'm going to run the script. And it verifies that everything that I have on here is available to run. when I first brought this up, for instance, it didn't have GCC on it. It didn't have several of these utilities that are needed. So I had to go out to the Synaptic package manager and install those packages. Once I had those installed, I now have the necessary tools to do the build. I'm going to skip through some of this stuff rather fast. The next thing you're going to do is you're going to need to know, where am I going to actually build this thing? So you may want to dedicate an entire disk to it, or you may only want to do a partition. Going back to my virtual machine, where I've actually got 2 different LFS systems built, and I will also tout what I think is the best way to manage this stuff, which is a little program which I'm sure many of you use, called gparted. And so here's good old gparted, and this is the system I'm running on now. And if you'll notice, it's showing that I'm running this under a MS-DOS type disk format, the old MS-DOS type. But if I go to, there's one of my Linux from scratch VMs. And if you'll notice, it's got its own disk here, and this one is done under GPT partition layout. And I've got it to have given it 100 gigabytes of space for that disk. So this is where I built this particular one. If you're going to, once you've decided which one you're going to build it on, you need to actually allocate the space, and then you also need to create an ext4 file system. This is within the book as to how to do this. You can also just do it under gparted. When you go to create the partition, you have options that will allow you to go ahead and create the ext file system for you. The other thing that happens is there's a little variable called shell variable called LFS that you're going to use to point to it. The LFS package requires you to go to a mount subvolume and create a subdirectory called LFS. And of course, nothing's mounted on here at the moment. However, I'm going to be making use of it soon. So I have a little script here. Let's go to, we'll do that one. Notice I tried to do it without being super user. Fix that. Okay. This is okay. So got the wrong one. So I've now finally got this mounted, and I also, when I created it, I created this variable called LFS, which just looks like, and I repurposed it for something else. Let me change that. This is the way the book will have it. And now, so when I say, it's now showing me well, that's because I had this set. Let's try that again. There we go. So now I'm set up here, and this is a LFS system that's already built. But just to show you, this is where you would be building. The next thing that you get to do is to download all of the source for the build. And we'll take a quick look at that over here. Going back through here to the read online, I use System D. And again, you can create either a System D or a non-System D system here. And we'll go back to here. And these are all the packages that have to be downloaded so that you can build the system. But this can actually be done with a single set of loads. Notice we're using a utility called wget, which is one of the ones we were asked to load. And we can then go down and load all of the systems at one time. The next thing you'll notice here is this thing called MD5 sums. All of the packages have an MD5 sum signature here. This is a security issue. When these packages were created, they did an MD5 sum. And so when you download it, you can do the same sum on the package and verify that they're the same. The MD5 sum utility will do that for you. And that's what's being set up back here. So for LFS, once you actually download all the source that you're going to need at one time. And I do manage, there is one exception that you want to make, and that's actually the Linux kernel itself. The Linux kernel version that you'll see in the book right now is 6.4.12. And this is in the form, the version is major minor patch. So version 6 minor, version 4 patch 12. Well, and in reality, you can think of it as 6.4 and 6.5 as being different releases. Part of this is because the Linux developers may put or remove certain features from the kernel, and when they do, things called the header files, which you need to compile programs, may change. And so when they go from one minor version to the next, generally there are some parts of the system that are dependent upon on the kernel headers, and they will have to be recompiled. However, the last one, the patch, is exactly what you might imagine. Bug fixes come in and they put out new ones. And so in the book itself, it'll point you back to the kernel. You can go back to that. go back to the kernel itself, to its website. We can go to the kernel itself, and here are a list of things. So if you'll notice, turns out 6.4 is already out of even long-term support. However, you can still get to 6.4, and you'll find that the latest one is 6.4.12 or 6.4.16. And so even after loading everything with the multiple load concept over here, you may want to go back, bring up the latest version, patch version of the kernel to pick up whatever bug fixes usually significant there. Once we've done that, we've gotten through all the hard stuff. First thing I want to bring up here is just to look very quickly at the general pattern for any compile. So if we go to just about any compile here, and I picked one back here, there we go. So that's what a page looks like for installing a particular package. It happens to be Gawk. And you'll look, and there's several steps that almost always occur. The first thing they have is they need to do a patch. So that's there. It's then followed by configuration. The configuration is generally going to be .config, and it's got all sorts of parameters that go with it. Or it will be something which is as a couple of years ago, people who were not happy with make and config, because they can be rather arcane at times, went out and through Python put together something called Meson, MESON, and Ninja. And that's slowly sort of taking over. There's not much within the basic LFS stuff with Meson just yet, but it'll, over time, I'm sure a lot more stuff will go. They work pretty much the same. Meson, MASON, allows you to set up configuration, which is to pick options. For instance, the very first option here says user, prefix \user. This is where we're going to build it. We'll probably put most of Gawk's stuff in user/bin. So you'll see there's all sorts of little parameters, and then make is going to drive the compile, and Meson Ninja will drive the compile for things that are configured with Meson. And then the last thing you'll see down here is the actual install. I picked one of the things that's in the cross compile area because they do some special things. But when you do the make install, this is when it actually puts the package in. So as you can imagine, you don't do this one if you get errors on that one. If you get errors on the make. And then, so just looking very briefly at the process, we've got all these packages put into one place. It happens to be a directory on your target partition called /sources. And so you go into there, you use tar, the XVF says take this particular archive and expand it, and it will expand into a directory. Not every package, but most packages will expand into a directory that looks like exactly like everything except for the tar.xz. So when you get through with this, you'll have a directory there. And I use the V. You don't need to. If you do without the V, when you run it, it'll sit there for a few seconds while it's expanding the archive, and it'll come back to a prompt. If you do the V, it actually shows you what it's expanding. It's, to me, sort of like the progress bar. I just like to see the movement. Once you've done that, you go into the directory, And then you can go through the steps of configuring, compiling. We'll talk about tests later. And once it's built, installed, and then finally you go back and delete the directory. There's a good mistake. So for anybody that's never done this, the RM, this particular thing is how you can delete a directory and everything under it. You do not need the slash. That was something I had to do early on, because, fighting the formatting system of LibreOffice. But anyway, so if I go through here, this directory that I created, and that will delete it. You can leave them expanded if you like, but generally once you've built it, you want to go ahead and get rid of it. So that's the basic process of everything you do. The next thing to talk about a little bit is you'll look through, you'll see these things called SVUs. As you can imagine, you're building these things, Linux, on lots of different places. And the hardware speeds are going to vary immensely. So what they did was come up with this idea of a source build unit. And the very first thing you build in your building your cross compilers is a thing called bin utils. And when you do that, the book will tell you how to time that. And however much time that takes, that's your basic unit. It'll come back to you in terms of seconds. Every other estimate in the book is then based on this. So for instance, if it took you 2 minutes to install bin utils, then if another place it says, say, 40 SVUs, which is I think somewhere around what it takes to do the final compile on GCC, you now need to go, it's going to take you 80 minutes. However, this is only an estimate, and sometimes it can be off a good bit. It's got to do with how many CPUs you're using to compile. And it can also have to do with such things as, again, the parallelism of the build, but also, are you building it on a disk? Are you building an SSD? How much memory do you have available for the compiler? How much time does it spend? And it can do this for some of the larger compiles. If you're running with a small amount of memory, it may be throwing this stuff out into swap areas, and that can significantly slow down the build. So bin utils itself is not a very big package, but if you're compiling GCC, it's huge, and it could definitely up your time. Having said that, we'll talk about the 3 different stages that you go through. And I'm not going to go through, there's information here I can make available. But the 3 stages are, first, building the cross compilers that you're going to build the final compilers. That sounds funny, but that's what you're going to do. Then you're going to build the actual tools, and finally you're going to build the system. The reasoning behind this is that you're ultimately going to be building stuff in root. Using root's always dangerous. Good typing mistake and you can erase your entire operating system. I just showed you the RM minus RF instruction there. If I did RM minus RF as root and put a slash there, it would attempt to delete everything on the disk. So you really don't want to be messing around being in root unless you absolutely have to. So the first part of this stage, they actually create a little user called LFS. And you go in as LFS and you do the initial set of builds as LFS. What this means is typing mistakes may screw up your build and you may need to start over, but you're not going to do anything bad to your system. Having done that first stage, you now go into the second stage of this building, which is you use those compilers and tools. There are only 5 of them that you build initially to build the tools that you're really going to use to build the operating system. This takes longer. For instance, the GCC build in the first stage takes typically not more than about 20, 25 minutes. Second stage is going to take a little longer. And this is the point that if you were having a separate target, you would now need to box everything up into some sort of an archive and send it to the actual system that you're going to build on. And then we get to building in the Chroot environment. I don't know how many people are familiar with the Chroot environment, but it's another way of protecting yourself against doing stupid things as root. So if you notice, back when I brought up the system back here, and fumbling as I was, I put it up here. Now, at this point, this disk is available. I'm actually running as root at the particular moment. What I'm going to do now yeah. What I'm going to do now is to go into where we got here, home. As I'm going to go in, some of this stuff at the top, you can read it in the book, what you're doing. You're actually setting up, because you're going into the Chroot environment, you not normally have access to a certain amount of the hardware. So the first sort of things are ways of giving you access to the hardware when you're in Chroot. Chroot itself now is going to set us up with LFS as our root directory and several other path environments, et cetera, et cetera. And when we finish, this is our new root. What's useful about this is that this particular root, this particular privileged user cannot get to the rest of the file system. It's only getting to this part of the file system. So now if I make mistakes here and decide to delete everything on the disk, all I've done is deleted my installation. I have not touched my host operating system. The last part of the building of the tools, there are several tools that need to be built in this environment. So we go through and do that. And then finally, once we've done that, we're going to we'll have built it. We're going to come back out, and this time we're coming in here for real. This time we want to actually build stuff. And one of the things that we're going to do that we didn't do in the first two is we're going to actually run some tests. In the book, it will tell you that whether or not you decide to run tests for packages you install is optional, with the exception of a few very critical components. And the reason for that is that if these components are screwed up, your system is not going to work. As importantly, certain kinds of errors will not show up if these are built incorrectly until much farther down the line. And it can be very frustrating to have to go back and restart because something at this particular area failed. So when you run, for instance, the last compiling of GCC, which takes a long time, runs a lot of tests, you get a lot of results. There are pointers in the books to where the developers ran those same tests, and you can check to see that your results are pretty much the same as theirs. I say pretty much the same because there are going to be some slight differences in the number of tests that pass and fail. They will generally point out which ones you don't need to worry about failing. And again, the reason that you may not want to do it is the test can take a significant amount of time, depending upon the hardware you're running. However, this is my own belief, is that if you're doing this to learn how things run the test the first few times and verify that things are running. After you've done that, which takes it's going to depend on there. The last few times I haven't done it completely manually for a long time. I'm using various forms of automated builds right now. It can take pretty much a good day and a half to get this system built. And I'm going to show you in just a second, just a sample of how you would do one of the builds. Some notes here about the various times, etc. Okay, so let's do that very quickly. I don't want to take too much more time here. Come back to here. This is this particular thing that I showed you earlier. Gawk is one of the ones that's done in there. So let's go to So again, this is an actual system that's already built. So one of the things that I do in building the system, everything initially goes to back to /sources. When I get to the point that I'm going to BLFS, I take it out of the / directory and move it under my user directory. That's why this is here. So we're going to build Gawk. First thing we're going to want to do is untar it. Boom, done. So, and then we're going to CD into Gawk. I'm a great, if you spend much time in shells, you learn how to do the completion keys. I just hit the tab key and it found the rest of this. And so this is what the directory looks like. Well, the first thing it asked me to do is this. I need to do this. So I'm going to copy that, come back over here, paste it. It's done. Next thing I'm going to do is the configuration. Copy that, paste it. And so this is what config does. Not only is it processing the particular parameters we have, but it's checking to see that you have all the dependencies that it needs. And that's what it's going through and doing. And then we can do the make step, which this one should be pretty fast. And everything is good. It didn't give me any errors. If I were going to do the install, which I'm not, since I've already got this installed, I would then copy this line and do the make install. And then finally, when I'm done, so it's all gone. So that's pretty much the process that you're going to follow while doing the build. Once you've done the major part of the build, let's go back and look at that. This is where we did the building of the tools, tool chain. This was this little bit that we needed to get additional tools under to root. And then this is the large number of packages that we have to build to get there. The next thing we do is we get to a place called system configuration. And I won't go through much of that. As you can see, you're going to need to configure the system clock, and you rarely have to do anything about the console. The locale is where you're going to say, you know, we're in the Eastern time zone, and you need to set that up so that when the system clock gets set, it gets Eastern time. These two files are pretty much just generally copied. And then we'll get to this one, which I really included under configuration, called FS tab. This is kind of an important file if you've never looked at it. This file is going to be used when you're booting to tell the boot process what files to use. And you'll notice that it's got this wonderful little stuff at the top. There's in comments it says this is on device DB1, but it puts this UUID here. And same thing for the swap file, and same thing for this particular file. When I bring up this operating system, I actually have a pointer back to Debian, to the Debian disk. And this one here would be for our mythical CD-ROM drive. You see the UUID. These are identifiers for the disk. The good news about them is it says, note that this is on VDB1. Well, not that long ago when I was doing a different compile, I had never seen a virtual machine do this before. It actually put the disks in a different order. When I came up within Debian, what I thought was DB1 was now actually DC1. However, by using this form of mount, the UUID, it didn't matter. It finds it. And if you ever need to find out what the IDs of your disks are, the little thing called block ID, and you can see for VDB1, etc. The part ID we'll talk about in just a moment, but that's pretty much it. That then gets you to doing the kernel. So we're going to build the kernel. The first thing is we're going to need a configuration file. And if you already have one, there's a way to deal with that. But assuming you don't, so I'm going to go here and do something real quick to make this work. So this would be the same as having a this would be the same as what would happen when I first come up if I had not yet generated the kernel. So now I've expanded the kernel subdirectory. And the first thing I have to do, and when you do this, by the way, you'll later on want to be able to do more than one run through the same directory to make changes. If you do this step again, this wipes everything out. This is sort of the making sure everything in the directory is clean. And now I need a config file. We don't have one. So I need one. Well, when you're doing this the first time, this is usually the easiest way to get one. However, what it's put together is a very basic file, and it may not completely reflect your hardware. But we can go through, and once we've done that, if we want to now make modifications to it, we say menu config. And sure enough, now we come up. So if I go into general setup, it says I'm going to compile drivers, it'll load, et cetera, et cetera. If I go down to, let's go down to device drivers here. Okay, here's all sorts of device drivers, and there's a ton of them. Maybe one of the most important ones is to come down here. It says, okay, this is my main disk, and I need to have ATA and SATA control. And so it's got all of that set up for me. And I'm emulating a particular device, which looks like one of these. And this is what DefConfig did for me. It figured out some of the things. And if you go down here, you can see there's just a ton of different things to go. So how do I figure out what hardware I might have to be able to make changes? One of the best ways, and we're going to go back to here, go back to the host system. If you've never done this, is a wonderful thing called proc, which has, it's a pseudo file system, but it will give you lots of information. So a thing called modules. These are all the modules that got loaded when Debian came up. I will either need, in order to run this hardware, I'm going to need most of these modules in one form or another. And particularly when I bring the system up and it craters because it doesn't have something, this is a good place to go back to find it. And how might I do that? So let's see if we have a USB core. grep's a wonderful tool. So let's just look for everything that within my config file. These are all the things with USB on them. Obviously, I need something a little more. So let's try the word core here. Well, let's pick something better. Let's go for virtual I/O. I know I've got that set. So here's all sorts of things with the word virtual I/O. And if you'll see, most of these things are marked yes. And I come down here and say, okay, have I got virtual I/O shared memory buffer PCI? Okay. And let's relate that back to memory config. So suppose I'm looking for USB core. I hit a slash key to get this help up. And I say USB core, no matches found. All right. Let's go to piece virt IO. So that's that one that we sound there, and it says, oh, this symbol here, it is set. If it was not set, and I needed to figure out how to change it, we can go down here, and it says it's defined at this place here, but more importantly, this tells you within the menu how to find it. So if I went under device drivers, and I went to the tab for virtual drivers, and I went to PCI drivers, you'll find all of those set. And it tells me what other things it may select. There's certain kinds of things. For instance, if I had not, virt.io doesn't have any way to be set directly, but it needs to be turned on if I'm going to have virtual I/O. So just a flavor of what you go through to figure out what's happening. And the other thing you'll find is that in the book itself for building the kernel, it will tell you a list of different options that you must either have set or unset to run LFS. And that little thing with grep and config is a great way to find out if you've got them set without having to spend a lot of time figuring out how to wander through the def config menu. So all this stuff that we did that you don't do when you have a distribution, this is a good point to just kind of briefly talk about it. How is it that Debian or Ubuntu gives everybody the same kernel and it runs on different hardware? That's because of the process that they use in booting. They put together a very basic kernel with all of the options that they want set, but it has hardly any hardware in it. It has things called loadable modules. Loadable modules are can be created. When you were looking where we had the yes and no, there was occasionally a /m and says, make this a loadable module. So when we make it a loadable module, it doesn't make it part of the kernel, but it puts it in a place, well-known place called lib/modules, that it can be picked up by the operating system during boot. And so what they do is they generate every conceivable modules that they think they may need during boot, and they throw them in this directory. It's lib modules, and then it'll actually have a subdirectory that corresponds to the kernel version. During boot, instead of loading the kernel directly, you actually do load the kernel, but you also go load something called a init read. And it goes into memory, and it's got just enough sense to go out and query the hardware, find out what you have, and load those modules that are needed to continue booting. Once it's done that, it then goes and starts the final part of the boot process, which if you're an old-time Unix person, this hasn't changed since Kernighan and Ritchie wrote it. The init process 0, is in run, and it's now running in an environment that has its disk manager, its graphics card manager, its keyboard manager, the mouse manager, all of that stuff available to it. For LFS, we don't do that. Instead, those pieces that we need during boot are always directly built into the kernel. And so it doesn't need to go through that particular part of the build. I did mention the difference between one of the few differences that show up while you're doing the build between the running with and without System D. I call the other one System V, that's System 5. In the book, they just say this is LFS, and then there's a LFS with S System D. What you will actually start is slightly different for System. The init process for System V will be different than the init process for System D, because they will use different methods of bringing all the rest of the stuff up. So the last piece of it, after you've done the make, I mentioned the fact that these modules, whatever modules you have asked it to build, are then put in the correct place with the make modules install. And finally, you're going to end up copying the image that you've just built, the config file, and a thing called a system map. You're going to copy them all out to the /boot volume. Then we're going to go and make the system bootable by updating config. And here's a quick picture on config. Let's go back to here. So this is, it says do not edit the file, but we don't pay any attention to that. Anyway, This is actually the same boot file that Debian's using here. And if we get way to the back here, these are what we actually use to boot the LFS systems. This has been added, and there's information in the book showing you how to do this. But once again, I'm using that UUID, except when you get to the actual system D image, and you'll notice it says part UUID. For some reason, when it loads the Linux image, it wants the partition ID and not the disk ID. So whatever, we do it. And if you notice, I've got commented out something about updating microcode. So real fast, we'll go back through here. And now I'm going to get out of here. When I did this exit, I'm no longer in the chroot environment. And I can unmount my disk. Oh, well, won't worry about that right now. And we're going to quickly reboot. And so this is a basic LFS system that I built recently. It will do more than this, but we're going to just bring this one up here. And there we go. At that point, this is about all I'd have. So if I want to do something useful to it, I will need to go into the BLFS system. I think I'm running out of time here, so I'm not going to go much farther. Anybody who wants it, I can send you a copy of this. But pretty much you're going to now go back, and I'll do a short look at what a BLFS looks like. You're going to go back and build the rest of the system. What I mentioned in here, this post configuration and extra software, this particular section 3 here helps you in setting up for a usable system, and particularly setting up for having a plain user rather than just a root user. So I can go back here, and when I come in, having done all of that, that's my regular user, and this is where I do the rest of the building for BLFS. Quick difference between installing for BLFS, and I have a lot of text about this that I won't have time to go through. You'll notice each one of the packages we now have the source pointed to, along with a lot of times both an HTTPS and an FTP location, and then the MD5 sum. It also tells you how big it's going to be, how long it's going to take to run it. So this, if you run the test, runs quite a long time. Various kinds of dependencies. Most of the time when you're building, you're just going to do the first two here. So it says, if I want to build GNU TLS, I've got to first build Nettle. You can think of it as having a tree. It will sometimes take a few rounds to get through. These recommended, this will build without having any of these packages in. However, some very, very useful features will not be available. As an example, you won't have the make CA is for certificates. You won't have certificates downloaded, etc. So although the recommended and required, you don't have to do the recommended, but you should. The other thing mentioned in there is a thing that you can now run into called circular dependencies, where you may need to build something more than one time. There's one that I always run into is something called free type and harf buzz. And when you you go through and get to that point, you actually have to first build free type, then you build HarpBuzz, then you go back and build free type again to get them correctly built because they have circular dependencies. There's a few others where you run into dependencies of at runtime, and that can create a circular situation. So a runtime dependency says I can build this particular thing without needing the runtime, but if I try to actually run it and I don't have the runtime installed, then it's not going to work correctly. So again, it becomes a circular thing. You first build the package without the runtime. You then go to the runtime, which may require the package. To the runtime package, you build it. Now everything's ready to go. I do have a list here, the last little bit. If you're actually going to do BLFS, one of the things you might find when you bring up that LFS system is you don't have a network. So these particular packages, assuming you have wireless, will get you access to the internet. So you actually build those not with the system you just booted, but you go back to the root environment for that system, and basically you build those packages in the root environment. The last one mentioned here, OpenSSH. Having SSH access to your new system when you're doing BLFS is a wonderful thing. The cut and paste that I was doing earlier from outside the VM into the VM is not going to work in the base LFS system. However, if you bring up SSH and you've now got a window running within your host, you can do your builds in that window, in that SSH window, and yes, you now have now you can do your cut and paste across that boundary. And I will leave that for another day. And one of the other things that you end up having to do is install daemons. These are programs that are running all the time. OpenSSH runs with the daemon, and you will find there's a separate step for building that. Depending upon whether you're building the System D version or the standard version, you will have different boot scripts. And last little do 5 minutes of is this thing called Automated Linux from Scratch. And I had not done this before, but actually in getting ready for this, I went ahead and did a little looking into it. It's really designed, to be truthful, it's designed for the LFS developers. But for instance, you can do this entire building of LFS. I did it in 6 hours. After going through the process of the initial configuration, which took me about 15-20 minutes, I let it run. And 5 hours later, I had a bootable LFS system. In order to get that, I had to give it some things, like I had to provide it with an FS tab, and I had to provide it with a kernel configuration file in order for it to do everything. But it did everything. I turned around and booted it. In fact, the system that we were just up under, this is the one that I built with ALFS. And one final thing to show you. So if after you've done a 1 or 2 regular LFS builds, if you want to do this, this is a great way to do it. The BLFS portion of this is much trickier. You find that for every package, you actually need to spend some time looking at the scripts and sometimes fixing them. This works fine if you're going to do this thing again and again, but it's a pain doing it the first time. And quite frankly, I think it's simpler to just go to the BLFS book and do copy and paste rather than the automated version, unless you're a nice bash expert. I'm not a bash expert. I did spend time in my career writing bash scripts, but I still hate it. Okay, and one last thing here. Let's do this. Oops. Okay. And this is the other LFS system. This one has also been through BLFS. It's about to come up. And I don't have a display manager, but what I do, which I find to be better than a display manager, is I have a little minor script that will start the desktop whenever I log on under my username, which I probably just mistyped. Yep. And there it is. There's a XFCE system that was built, has all applications, et cetera, graphics application, virtual terminals, all that good stuff. So that's about it, I believe. I'm done. Anybody have any questions?
You are muted, Gene.
You're muted.
I've got 43 questions.
I was just wondering, there's always a back and forth about System D. Without going into a big rigmarole, what's your down and dirty on? And I know
Okay.
you use System D. I didn't know that was because you had to or because you wanted to.
No, I chose it sometime back. Okay, so without the first thing is, whether they like it or not, everybody uses part of System D, because this thing called UDEV, which when you boot your system these days, if you go back before System D, you had to build the dev directory and you had to populate it. And what UDEV does is during the boot process, it goes out, finds your hardware and builds that for you. And everybody likes that. What people generally don't like is the initialization scripting, the stuff I talked about for daemons. System D uses what looks like a file with a bunch of simple instructions in it as to how to do it, which you can also extend with regular scripts. Init, which goes back to System 5, why I call it System 5, is a bunch of bash scripts, and I can read them fine. I find them arcane, so it's a matter of I'd much rather deal with the System D version. The other piece that people tend to not like, and here I'm not crazy about it, is the journal. This is a system log. For System 5D, it's a nice simple text file. For System D, you've got to use a program called Journal Control in order to read it, though it operates a lot like LESS. You can do searches on it, etc. So I think the worst part of System D, and what I think was the mistake that the people who built it initially, which are people out of Red Hat, by the way, if you didn't know, they put all of this thing in a single package. It really shouldn't be in a single package. You should have the UDEV part, you should have the journal control part, you should have the startup part is separate things, and then people can pick and choose. Over time, I suspect probably because of the clout that Red Hat have, most distributions these days use System D. There's some that don't, but the larger ones, Debian switched over, I don't remember, it was about 2 or 3 years ago, to using System D. And, again, I've been part of the flame wars on it. And I don't have that much religious zeal for it, but I just prefer to use it.
Okay, thanks.
So I have a question.
Mm-hmm.
Uh, can you do this on older hardware, 32-bit machines?
You can. It's a lot more difficult. They still have a 32-bit, but it is not as well maintained.
Yeah.
Up until, I'm going to say, about 2018. I've been doing this since 2010. So up until about 2018, you could get both a 32 and a 64-bit. But the number of people that wanted a 32-bit machine was vanishingly small. But you can find it. I could locate it for you, and if you would be interested. I find it a little. There are approximately, if you look at the credits at the moment, there are about 8 developers that maintain this entire system. And the LFS is a small part. The VLFS is huge. And I think it's basically down to they didn't have anybody that was interested in maintaining the 32-bit system anymore. And so that's why it's fallen off. These guys do an incredible job. And as I mentioned, they're very helpful. Probably the only thing everybody should be aware of, because it's the newbie mistake. The term top posting. When you respond to an email, and a lot of us do this, I'm guilty of it most of the time. A lot of times, your original text of the email is copied, and then when you start writing, you're writing above that. Well, when you're trying to answer questions from users and you want to put it into an archive, it really doesn't make any sense to do it that way. It's literally, you should, if you're answering a question, you should put what your answer below where the question is asked, or if you're interspersing in between. So they definitely don't like you to quote unquote top post. So if you're responding to something, you send a question in, they respond, and you want to ask a further question, go to the bottom of the post. But other than that, it's very helpful. Nice guys. One guy is in England. There's one guy in America, 2 guys in France, and a couple of guys in Germany. So
Amazing. What about older drivers or drivers for older hardware that may have to be updated, or how do they handle that?
That's going to depend. Well, there's 2 different answers to that. So if it's non-proprietary, the kernel, if you go into the kernel, you can find a lot of old hardware. In fact, I just kind of very quickly breezed through some of it. But for instance, if you go look at network cards, I swear there may be 500 or 600 in there.
Really? Whoa.
Yeah, really. Plus, of course, I didn't mention firmware. That's one of the things that they don't provide that you have to copy. I always copy the firmware out of one of my systems and put it on there.
Gotcha.
Yeah, because that's and I'm amazed at how old the hardware they support. One of the things and even for proprietary, I run on Arch, and I have a very old graphics card that's going to get replaced tomorrow. But this is an old NVIDIA card, and NVIDIA stopped supporting it about a year and a half ago. And so somebody within the Arch community has done the patches or whatever to get the new one out and provide it for us. So the kernel had no problem with that. It was just that, if it's a graphics card, it's got to talk to the GPU, and that's the stuff that NVIDIA keeps to itself.
Right. Okay.
Pat, I wanted to ask a couple of questions, but I wanted to first of all thank you for what I think is a wonderful presentation. Absolutely wonderful. especially for somebody who's never built this before. I have successfully built a Linux from scratch, but it was about a year ago, and it was using the 11.3 manual.
Mm-hmm.
And as you know, when I had to email you a couple of times, I've attempted twice and failed twice to build it under the 12.0 manual. And I could not figure out to this day why the build didn't work, why I was not able to boot up. I think you answered my question in the presentation, and I think it has to do with the kernel going from 6.4 to 6.5. I think that probably is the reason. And but I got a couple of questions things that I noticed when you were doing your presentation. First of all, I wanted to applaud you for using UUIDs in the FSTAB. A lot of people don't do that. I do it, and because if you move things around, it finds it, and it doesn't have a trouble doing it.
Well, yeah, like I said, I was completely shocked when I brought up the VM. I've never had a VM do that, and it swapped two of the disks.
Yeah, exactly.
And when I came back up the next time, they were back to normal. I have no idea why they do that.
The question I had, though, is I noticed in the FSTAB that you had an ext4 file system, extend4 file system on the boot partition, and wondered why you weren't using like VPAT, F32, or perhaps
Okay,
ext2.
So there are two different things there. And what you saw right now, I have it set to actually boot from the old MS-DOS form that I put Debian up on. When I went to install Debian, it didn't want to install the UEFI, and I wasn't going to fight it.
Yeah.
And so it put it up on an old format disk. So that was fine. But when I brought up my own, I formatted the disk with GPT, and whether or not you're going to use the MS-DOS boot or not, it's having a GPT disk to me just makes a lot more sense. It's a lot cleaner. However, for setting a boot, when Grub goes, if you want to make a disk, the actual boot disk, rather than the boot for my virtual machine is actually done on the Debian partition. And then when it comes down and it finds that, oh yeah, I want to boot the third line, okay, I need to go out to this other disk and do everything from there. If I wanted to, and I did for which you saw was the second VM, if I want to boot from that disk and I go through and fix the virtual firmware to point to that disk as the boot disk. If I'm going to boot it with the old style Grub, we call the MS-DOS thing, you need to leave about a 512 byte gap. And it really doesn't care what file system you put in that little partition or that area, it's going to write over it. Okay. If you're going to do UEFI, that's a whole different thing. Now you need about a 2 megabyte partition
database,
and it has to be formatted, as you mentioned, to the FAT NTFS. That and that's where and there's I think about 2 releases ago, LFS put information on how to put a UEFI boot. For my regular machines, I use that. I have for this one that we're running on is a UEFI boot. So.
Okay, well, I always used the DOS partition and used the old MBR format process. But I never put an ext4 on there on the boot because I didn't see a reason for journaling it. And because ext4. Now you can remove journaling feature from an ext4 file system.
You did see how fast that sucker boots on the.
Well, I'll tell you, the first build I did under the 11.3 manual, Pat, took me 5 days.
Yeah.
I mean, because some of the things like glibc compile, it took 5 hours to compile it.
Yeah. Oh, yeah. No, it can take, depending upon the hardware, it can take a lot of time. The current, I will say the current SBU on the initial GCC is wrong. It's off by a lot. But again, when I ran it under ALFS, I was really surprised. I didn't expect it to be that fast,
Yeah.
but it was only running the required tests. That is one feature.
Well, that's the other thing. I ran all the tests, and the
Yeah.
tests took longer than the compile.
Oh yeah, no, and that's yeah, and I saw it with ALFS, and the fact that I was bringing up a version that I had brought up a couple of times already, so I wasn't worried about finding any problems. Now, the other problem you probably ran into, and I lightly skipped over. This is the first time it's happened. There was for those of you who don't know what glibc is, glibc is how you get to the operating system. When you're in a program and you make a call to the operating system, it goes through glibc.
Right.
And it may go into the operating system. It may go a few other places. So this is a very basic part of the operating system. Well, about 5 months ago, they found a very serious 0-day bug in glibc. And so it is so serious that normally you saw the place where you can apply security patches. There, if you looked at it very carefully, they recommend applying this patch before you actually build LFS, and it doesn't patch the entire library. It patches a specific part of the library. So there's an elaborate set of instructions as to how to, if you've already got a working glibc, how to go back and retrofit that. But they also recommend that you build from the top with that. And I'm not sure that didn't give you some problems also.
That's possible. But
Yeah.
anyway, I wanted to thank you. You did a great job.
No problem. Thank you.
Does anyone else have any questions? Well, thanks so much, Pat. That was awesome. I think this is it's been a while since we had something so very core to our function. But yeah, this is something I've been wanting to do for a while. Installing a Gen 2 system is similar, but not nearly as as base level. And it's been ages since I've even done that.
Yeah, well, I think it's worth. I did it. Like I said, I read the first time I did it was, and I'm saying 10 years ago. I'm not exactly sure. It was version 6.2 of LFS, and as I said, because I still do software development, I find it useful to have access to source for everything. And so sometimes when I run into problems, I'll take that same thing that I'm working on and put it on an LFS system and see what happens. But you learn a lot about the operating system by building this, and you learn.
Absolutely.
Yeah, and you get used to, and I haven't done Gen 2. I similarly probably have some better understanding of some of that base configuration.
I'm doing that now.
Yeah, the dot profile file for bash that you don't realize that you execute every time you bring up a system has a lot of stuff in it.
Oh, yeah.
And if you can break it real easily. I didn't get to talk much about sudo. It's a very useful tool, but one of the things I do appreciate about the way the LFS developers do, there are times when you're running root in your host system, but you're doing very few things at that point. Almost everything is done in the root environment, which says, if I mistype something, like I said, I've known somebody who did it, who did in an rm -rf / and they left the space before they put the name of the directory they thought they were going to be deleting. And if they had not had a backup, they would have been completely and totally hosed. You can truly shoot yourself.
As you know, Pat, sudo by itself is a security risk.
Oh yes, absolutely, and that's why in the presentation I mentioned that when doing the BLFS build, it is very convenient to set sudo up so that you don't have to enter a password. And I do that. However, when you're done, make it give you a password again. Or as I said, you can delete it altogether and make use of just SU. So,
Pat,
yes.
I think I'm running Linux with the XFCE system, and I think my total files, when it comes up in the beginning, total files and folders, is something like 250,000. What is there a big difference between that and the LFS system?
Yeah, there's the obviously for the basic desktop itself, there's not going to be much difference, and it's got somewhat to do. For instance, if you go into the BLFS, you'll see there's a little section for building XFCE. However, before you built XFCE, at least on LFS, and this will change over time because of a thing called Wayland, but right now you build X server. And so you go through and build a bunch of stuff for X server, and then on top of X server is what you build the desktop. But then after that, there's another section that says XFCE apps. So for instance, things like XFburn, Ristretto, all of these little utilities. Well, when Debian or whoever your distribution is brings up XFCE, they decide on a whole bunch of other stuff that you may or may not need. And, if you go through your menu, you may be able to look at things and go, and what exactly is that? Well, one thing I can tell you about an LFS system, if you go through the menu and you see something you don't know, you're going to be surprised because you asked to install everything. Now, the other thing about doing BLFS is dependency management is a little bit of a nightmare until you get handle of it. But yeah, you can end up if, for instance, in trying to install XFCE, you can find yourself having to install a lot of different files because, for instance, you need audio support. So you need Pulse Audio or you need ALSA, etc. You're going to have a bunch of graphic tools you're going to want to install. If you're going to have a web browser, you got a lot of graphic tools that you want to install because of what's out there. So that's kind of how the numbers grow, is from that. But again, as you're building in BLFS, you find out what all of those are. And, there's right now at LFS, they're going through an exercise of figuring out what they're no longer going to support in BLFS. And you'll find out, they said, well, for instance, there's a program, and I know I've got a copy of it. Let me check for the name of it right off the top of my head. Oh yeah, ABI Word. ABI Word is this wonderful little program that somebody wrote, which reads Microsoft documents. Well, nobody's maintained it for 2 years. So they're looking at removing it, which makes perfect sense. I think most people on open source are now using LibreOffice and they don't bother with ABI Word anymore. That sort of thing. So, and I don't know about other distributions, how much time people spend in saying, well, does anybody really care about this anymore? So.
I got a question, Pat, Rusty here. Can you just give I have two questions. Can you give a blow-by-blow description of the dangerous maneuver for the remove command that I think you said was a /RF, but then was based on a simple space, which I would call a space an omission rather than a commission.
Yeah.
So just to elaborate that awesome error.
So there's this wonderful form of the remove command, RM, and when you put a -RF there, you've done two things. You said,
yes,
I want to do it recursively. So not only do I want to delete this directory that I'm about to give you, I want to delete everything underneath that directory. Okay, so -RF. And unless, and you should actually have this done, I have it done on this system, but I don't have it in the VM. You can go in and set an option, and I've forgotten where it is, for RM that says anytime root does it, add a little I in there. And I'll talk about the I in a second because it's real important if you're root. But if you just say RF, the other thing that RF does is it says, don't report any errors. If you can't do it, don't worry about it, but do what you can. So when you do an RF, you're pretty much saying, do what I ask you to, and don't bother me if it doesn't work. Well, unfortunately, the next thing that's going to come up after the RF, the F says file. Now I need the form of a file. So if I say -RF ABC, well, whatever my current directory is, that's actually what the ABC is going to go after. It's going to say, you know, if you saw me using this squiggle Pat D, that says the user Pat D's directory / blah, blah, blah. So it goes through and does that. And that's perfectly fine. And if you were stupid enough to delete the wrong thing, well, so be it. But you're not dead. However, particularly if you go to delete something. So let's pick something you might want to delete. So you say -RF /temp, TMP. These are temporary files anyway. They're going to probably disappear at the next boot. / for some reason you want to delete a specific item in there, and you have to do this as root. That's going to work fine. But suppose instead you put / space and then TMP. Well, the RF command, like many basic tools in Unix, Linux,
God, yeah,
says I'm asking for two different files. I want /, which I've said delete everything, and then I want TMP. But of course, by the time you get to TMP, there's nothing there anyway. But that's the reason. That's what. So I like to use that just as an example of something really stupid, and you can do and with an accidental space. And if you probably watched me typing in there, I'm not the world's best typist.
Yeah.
And after 40 mumbled years in the computer business, you think I'd be better, but I'm not. And so the other thing I mentioned about, which is, and I'd have to find it where you do this, I think it's done within the configuration files for root within its directory, the dot files, is that you turn the RM into an RM -I. And what the I says is, when I ask you to delete something, ask me about it anyway. So if I had said RM -I / the first thing it would have done, whatever the first file it was going to delete, it would say, do you want to delete this? And at that point, I could have probably figured out, oh, crap, I'm deleting something very important. So you'll find, and you can look it up on the internet, several ways of wiring RM so that it is not as dangerous at root. Now, as regular user, you probably don't care. But that's sort of the normal way from a command line to delete something. And of course, if you're doing it from a desktop, they're provided you with the trash can, and you're not quite as dangerous. But when you're doing it from the command line, when you say remove, you're saying remove.
Yes. Here's my other, thank you for that. Here's my other question. Can you elaborate on that 0-day bug and how the various distributions dealt with it compared to how the Linux from Scratch community might have dealt with it?
I'd have to go back and look at if you look in if you go into Linux from Scratch and look where I look, they'll point you to a CVE. If you know what CVE is, that's the bug reports. And I'd have to go find that to say exactly what the bug was. It's a small, I don't know if I just remember, I just recently read a book on hacking and got reminded, if any of you remember the shell shock virus. This was about 6 years ago, and there was a day one bug in Bash that created a major security hole, and they ended up calling it shell shock. And with all the servers out there that run Linux, this was a huge deal. And you know, Bash itself, which coming from Bourne Shell, and I think the bug was there as well, at that point was like 40, 50 years old, and nobody had ever found it.
Wow.
Yeah. Yeah. So the way the distributions did, and I watched it as soon as I saw it talked about in the LFS directories. I checked I update every day from Arch, and I checked, and within a day they had sent the patched version of the bug into Arch, and Arch gets its stuff primarily from Debian, a lot of it. So my guess that particularly things like glibc, I guess that Debian had already updated it. Whether, you know, how that information depends upon how often you update your system, or whether you got from, if it was a commercial system, I would assume Red Hat would have informed you that you needed to perform an update, or if they're probably already doing it automatically for you. But it got fixed pretty fast once it was identified. But
yeah, generally there's like a secret. No, it's not secret, but there's the people that maintain systems are on a different mailing list that lets them patch and response and build the packages before the CVE goes public a lot of times.
yeah, that's what should be done. I worked as a software developer and operating system for Tandem for years, and one of the first things I did when I was a developer there was to create a security bug. That was really fantastic, and it was done actually in a debug program that would allow you to become privileged user. When we fixed the bug and we put out the fix, the text for the fix said, "We fixed a bug." We fixed the security bug. And the reason is the obvious one. If you tell people what the bug it is you fixed was, they can go out to systems that have not been updated and exploit it. And you know, because of the nature of the internet and all the stuff now, the CVEs have to do this. But I've often thought about the fact that it would be much better often if Microsoft or whoever just said, "We fixed a bug. It's a severity bug. Install this update."
Yeah, I mean, I guess there's that's the trade-off, right? Is if Microsoft's not so bad because, you know, it's hard to tell what changed, but for open source, it's like, I think security researchers look at those updates, whether they fixed a bug or added a new feature, and that's like a lot of times a good place to look for new exploits. Because
yeah. Well, and I'll give you one of my soapboxes for someone who spent a lot of years as a software development. The current trends in software development are that I'll put it, this is oversimplified. You sit down with the user, figure out what he wants to do, produce the software and release it. If you do any kind of QA before it's releasing, it's based on the tests that the developer wrote, because you're worried about getting stuff out to market fast. The problem with that is QA should not get their tests from the developers. QA should get their tests from the requirements documents or whatever their equivalent. They should say, okay, this is what the thing's supposed to do. Let's write tests to see if it does it. And they should get tests from developers, but those are the regression tests. When the bug is identified and I fix a bug, I would always create a test to check that I fixed the bug. That goes to QA, and they can run that to make sure that it doesn't show up again. But again, the software development cycle is such that the same sort of bugs that have been creating huge holes continue to be written. People continue to allow buffer overflows. The most basic of the things. It's, as you said, just the nature of the beast at this point.
That's why we should all switch to Rust, right?
Yeah, exactly.
But yeah, there's always bugs, right?
Yeah, well, and there's the other thing is, and I worked for support in a few years before I moved into development, and I used to have a couple of one of these little saying sorts of things, and two of them that went, it's hard to make it's hard to make something proof. It's impossible to make something damn fool proof because fools are so inventive. Yeah. And there's a lot of truth to that, and a lot of times it's because as a developer, you don't think of why would you don't make why would anybody do something this stupid, and they do it, and that's when some sort of weird bug shows up because they're doing something you had not anticipated.
Yeah. Oh, show.
All right. Well, it's going to be time. Any last questions for Pat on the topic?
I had a trivia question. Speaking of Rust, was the Linux kernel has some drivers build Rust now, right? Was this included in this Linux from scratch in 6.1 or 6.5, whatever the kernel version was, or was that not included?
I have no idea. Every time, well, I didn't show you one of the other things. So for instance, I do multiple Linux from scratches. When I get ready to do the next kernel, let's say go to the 6.5 kernel that was mentioned. When I go to do that, I can use another little make thing called make old config, where I give it the configuration file and I write this thing and it goes through and it says, oh, here's a new option. What do you want to do about it? And they will have defaults. Most of the time I'm going to take the default. Most of the time with Linux, when from scratch, 6 months later I've done it, I've got to answer probably 30 or 40 questions. That's how fast this stuff changes right now. Mm-hmm. It's incredible. So it's out there.
Gotcha.
Well, again, thanks, Pat, for the presentation and answering all our questions. Any announcements, urgent news from anyone unrelated to Pat's presentation before we call it today?
I've got something that may be of interest.
What you got, Pete?
2 or 3 weeks ago, up on my mountaintop outside of Asheville, the Skyrunner guy came riding by in his truck looking at all the poles. And I waylaid him to find out what was going on. And part of the Infrastructure something act that the government passed, a lot of money was provided to provide internet service to underserved areas. And my area is evidently considered underserved. And the government is going to pay to run fiber to my house at no cost to me. The only thing I have to do is buy a $150 fiber router of some type. Timing is within the next 6 months to a year. Skyrunner said the way the government handled it was they put lists of addresses up that were available to be included, and then the providers bid on doing the installation, and the winners of the bidding were awarded those addresses. Skyrunner bid on Fairview Forest and Flat Top Mountain, about 200 residences. and they were the winning bidder, and that's why he was up there running around trying to find out how the heck are we going to do this. But for me, it's like my speed right now is 5 megabit, and this is, I think he said 100 gigabit on the fiber. I can't imagine.
That's a bit of an upgrade.
Yeah. So it's going to be interesting to see how this all shakes out. But if you're in a rural area, you might want to check with your provider and see if you may be possibly included in the fiber to the home. That's it.
Thanks, Pete. Anyone else? All righty. Well, thanks all. I guess I'll see y'all in December. Do we have any notions for presentations for next time? Pat, did you want to come back and do a Beyond Linux from scratch or Advanced Linux from scratch? Or?
I could do the other part of that presentation, given that it's pretty much already written. But that's it. I had made it to be much shorter because again, it's more about what's different.
Well, certainly you're welcome to do so. It doesn't sound like we have something planned for December just yet, but we'll work on that. Thanks all, and
thank you,
have a great
Brett.
month.
Thanks.
Happy
Bye,
Thanksgiving.
Happy Thanksgiving.
Happy
Okay,
Thanksgiving.
bye, guys.
Bye.
Bye.